Lots and lots of real-world applications when it comes to exponential functions. So here we have the population of a strain of bacteria increases at a rate of 25% every half hour. If 2 bacteria were in the dish at first, write the model for the population growth of bacteria. So if we come up with a model, let's just say, let's call it B of t since we're talking about bacteria, and it's a function of time. We needed an initial amount. We started with 2 bacteria. We are increasing, so we're going to do 1 plus our rate expressed as a decimal. This is exponential growth that you learned in Math 3, 1 plus the rate raised to the t. Now, you need to indicate what t is measured in. It looks like we're given hour here. If we look at the question that's about to be asked, it's in hours, so we'll say t is in hours. T in hours. You always need to make note of that because sometimes they like to throw different units at you. Okay, so the question is, that's the model. A lot of times, though, you will see that they will add the 1 and the 0.25, so they will condense that to 1.25. Just be aware of that. It's the same thing. It's just adding those 2 numbers together. How many bacteria will be present after 4 hours? Do we plug 4 into the equation? Somebody said no. Why not? Because it says every half hour. Our rate is every half hour. So after 4 hours, how many half hours have we had? 8. We're actually going to plug 8 into our equation here to evaluate. So nothing in terms of actually solving an exponential here. This is just simply evaluating. But I wanted to use this as an example to illustrate that sometimes they will throw those little details in there with the units. So technically we should have said that t is in half hours up there when we were defining the function. T is in half hours, not hours. Okay, so just make sure your units always agree when you're using these models. Okay, let's look at another one. Let's look at example 7, the human memory model. Students participating in a psychology experiment attended several lectures on a subject and took an exam. Every month for a year after the exam, the students took a retest to see how much of the material they remembered. The average scores for the group are given by the human memory model. This is a natural log function where t is between 0 and 12, so that means we can only apply this function from time 0 to time 12 months. We can't apply it past those 12 months, where t is the time in months. What was the average score on the original exam? So the function, the average scores are given by this function. If we want the score on the original exam, what do we need to plug in? 0. Time 0, that would be the initial testing date. So we've got, I'm going to work this out a little bit by hand just because I want to remind you of a log property here. 0 plus 1 is, of course, 1. The natural log of 1. Remember what a log means. It means the base raised to some power is equal to that number inside the log. So e raised to some power is equal to 1. What's that power? 0. Anything to the 0 power is equal to 1. So really we've got 75 minus 0. So 75 was the average score on the original exam. Let's see how much it dropped. At the end of the first year, okay, plugging in 12. Now, we are going to have to use our calculator on this one. So 75 minus 6 natural log of 13. At the end of the first year, they went from a 75 to, well, failing in the college world. Well, failing in our world too. Less than a 60s failing. So failing right there, 59.61 after a year. Now, let's look at a scenario where we actually have to do some manipulating here. When was the average score a 65? So this time, we're not plugging in 65, we're setting our equation equal to 65. Now we are solving for x. So we need to use our log solving skills here. We've got to get the log by itself first. So we subtract the 75 from both sides. Then we need to divide by that negative 6. So that reduces to positive 5/3. So the log is by itself. The only way to get the variable out is to write it in exponential form. It is base e. So it's e to the 5/3 is equal to x plus 1. Last step, we subtract 1 from that. I don't know about you, but I do not want my test score reported to me in terms of e. I would like to know that number. So e to the 5/3 minus 1 x, or I think it was originally t, wasn't it? 4.294. Well, what are we talking about? That's the 4th month. So during the 4th month. So kind of quickly gets to a lower score. We were at a 75 originally, and after 4 months, we're already at a 65. So kind of interesting there. Any questions about what I've done so far?